Hi, this is Mr. Mack. This is a video about Cramer's rule. Now, Cramer's rule is a method of solving systems of simultaneous linear equations using determinants. So before we can actually go to Cramer's rule, we have to talk about evaluating determinants. Now, a determinant is a square matrix with a defined value. Now, in this video, I'm going to show you basically how to evaluate 2x2 matrices, or 2x2 determinants and 3x3 determinants, and we'll leave it at that. So first of all, if you have a 2x2 determinant, let's say we have R, S, T, U, then the value of this determinant would be the product of R times U minus the product of S times T. So I always like to think of it this way. The product of the down diagonal minus the product of the up diagonal. R times U minus S times T. An example of that would be 3, 6, 1, 7, for example. The value of this determinant would be 3 times 7 minus 1 times 6, or 15. Let's just try one quickly for you. How about this? Find the value of 2, 2, 5, negative 3. Okay, now I will pause the video. Well, I won't. You should pause the video, figure out what the value is, and then come back. Hi, welcome back. Now, the value is 2 times negative 3 minus 5 times 2. So we get negative 16 in this case. Remember, the product of the numbers on the down diagonal, 2 times negative 3, minus the product on the two up diagonals, 5 times 2. Now, if you have a 3x3 matrix, it gets a little bit more, or determinant gets a little bit more complicated. Let's just put one in here. 1, 2, 4, negative 3, negative 1, 5, 1, 2, 2. Now, the way we evaluate a 3x3 determinant is by using the rules of diagonals. Now, what we do is we take the basic determinant and we write the first two columns again. So we've got 1, negative 3, 1, 2, negative 1, 2. Now, to evaluate this determinant, what we do is we take the three down diagonals and the products of the three down diagonals, and we multiply them each and then add those three down diagonals together. And from that, we subtract the product of three up diagonals. So first of all, the down diagonals, 1 times negative 1 times 2 plus 2 times 5 times 1 plus 4 times negative 3 times 2. Now from that we subtract the product of the up diagonals. Let's see if I can come up with another color here. How about this one? Okay, so for the up diagonals we have 1, negative 1, and 4. We have 2, 5, and 1. And we have 2, negative 3, and 2. So from what we have above, we subtract 1 times negative 1 times 4 plus 2 times 5 times 1 plus 2 times negative 3 times 2. Now, doing all of the math, we get negative 2 plus 10 is 8. Minus 24 would be negative 16 for the purple part. From that, we're subtracting negative 4 plus 10, that's 6. minus 12, that's negative 6. So this becomes plus a positive. We get negative 10 for the result of our 3 by 3 determinant. All right, let's have an example for you. And once again, once I give the example, pause your machine for a minute and work it out and then come back. Let's see. So 4, 2, 1, negative 1, negative 1, 7, 3, 2, 2. And it is time to pause now. Hi, welcome back. All right. To find this determinant, we write again 4, negative 1, 3, 2, negative 1, 2. And then we have 4 times negative 1 times 2, that's negative 8, plus 2 times 7, that's 14 times 3, that's 42, plus 1 times negative 1 times 2, that's negative 2. From that we subtract, you see this is 3 that we're adding together. From that we subtract the up diagonals. 3 times negative 1 times 1, that's negative 3, plus 2 times 7 times 4, that's, I think, 56, plus 2 times negative 1 times 2, that's negative 4. So in the first one, we get 32 minus, well, let's see, 56 minus 7 is 49. So we have 32 minus 49, which gives us negative 17, I believe. So the value of the determinant here would be negative 17. Now, I haven't really checked these on the calculator. I certainly hope I'm not making any silly mistakes, but that would be how you evaluate determinants. Now, let's take a look at solving a system of simultaneous equations using Cramer's rule. Now, first of all, let's use a 2 by 2 system. How about 3x plus 4y is equal to 10, and 2x minus 7y is equal to negative 3. Now, I trust this one has a nice solution. Okay, first of all, when you're solving a system using Cramer's rule, we want the equations in standard form. Notice both of these equations are in ax plus by equals c form. Now, I'm going to refer to the coefficients in front of the x's in this system as the x column. I'm going to refer to the coefficients in front of the y variables, the y column, and I'm going to refer to the numbers on the other side of the system, the constants. First of all, you need to know the coefficient matrix. Now, the coefficient matrix is simply all the coefficients of all the variables. In other words, the coefficient of all the terms on the left-hand side of this system. In this case, it would be the matrix 3, 2, 4, negative 7. Now, spend a moment, pause the video if you need to, and look up at the system and see where the 3, 2 came from and where the 4, negative 7 came from. Okay? Does everybody see that? You need to see that. Okay? Now, we then are going to define 2 other matrices, and one is going to be n sub x, and the other is going to be n sub y. Now, n sub x is going to be the coefficient matrix with the x column replaced with the constants. In other words, it's going to be 10, negative 3, 4, negative 7. Now notice, if you take the coefficient matrix and you put a 10 where the 3 is, and a negative 3 where the 2 is, notice you will get n sub x. In other words, you have just taken the x column, 3, 2, and you've replaced it with the column that is the constants, 10, negative 3. Nothing else changed, just that one. Now, if you take the constants and replace the y column with those, you'll get n sub y. Now that's going to be 3, 2, 10, negative 3. Now note, oops, that should be straight up and down line there. There we go. Now notice what we've done here is we have put 10 in where 4 is, and we've put negative 3 in where negative 7 is in the coefficient matrix. And when we do that, we get n sub y. Now Cramer's rule basically says that if you have a system, x will be n sub x over the coefficient matrix. Oh, I didn't mention this. Usually, I like to refer to the coefficient matrix as big D. So Cramer's rule says that x will be n sub x over big D. In other words, n sub x is the value of this 2 by 2 determinant right here, and big D is the value of this determinant right here. And it also says that y will be equal to n sub y over big D. Now, let's just stop and talk for a minute. Why am I calling the coefficient matrix big D? Well, I'm calling it that because the coefficient matrix is always going to be the denominator in Cramer's rule, and so D, denominator. I tell a horrible joke, probably told it in class already to some groups, that math teachers all over the world were going to have Arnold Schwarzenegger do a movie for them. We were going to call it The Denominator. Anyway, getting back to work here. The n sub x is the numerator for Cramer's rule to give you the value for x. And n sub y is the numerator for Cramer's rule that will give you y. Now, let's just go ahead and do a little math here. So, for example, first of all, a defined value for big D is going to be negative 21 minus 8, or negative 29. Now, the value for the numerator, n sub x, is going to be negative 70 minus negative 12. And that's going to be, what is that? Plus a positive, that's going to be negative 58. And the numerator for y is going to be negative 9 minus 20, or negative 29. Now, Cramer's rule says then that x is going to be n sub x, which we found to be negative 29, over big D. Oops, excuse me, that's backwards. We found n sub x to be 58, negative 58. So n sub x, negative 58 over big D, which is negative 29. And if you think about it for just a minute, if you multiply negative 29 times 2, you get negative 58. So Cramer's rule is saying that x in this case is going to be 2. Now, n sub y is negative 29, and big D is negative 29, so we get 1 for y. Now, let's just check and see if this makes any sense. If x is 2 and y is 1, 3 times 2 is 6, 4 times 1 is 4, and 6 plus 4 is 10. 2 times 2 is 4, minus 7 times 1 is 7, and 4 minus 7 is negative 3. So that actually does solve the system of 2 equations in 2 variables. Now that's pretty cool. All right, let's try one that you could work on. Let's come up with another system here. How about negative 2x plus 3y is equal to 1, and x minus 4y is equal to, let's see, negative 16. All right, now, right now, what I'd like you to do is pause the video and work through this problem. And when you come back, I will, in just a moment, I will actually go ahead and do the solution right here so you can see it. So now would be the time to pause. Hello, welcome back. Now, to solve this system, first of all, the denominator determinant would be -2, 3, 1, -4. Now that gives us 8 minus 3, or 5. Now n sub x is going to be 1, -16, 3, -4. Now that gives us -4 minus -48. Something's wrong here because this was supposed to work out evenly and it doesn't look like it's going to. I must have made a mistake someplace, but let's keep going. N sub y is going to be -2, 1, 1, -16. Now that gives us 32 minus 1, which is 31. All right, so x is going to be -40, let's see, 44 over 5, which is, what is that, 8.8, and y is going to be, let's see, was that right? No, yeah, 48 over 5, and y is going to be 31 over 5, or 6.2. Now let's see if that worked. I mean, I'm afraid I've made a mistake here someplace, but maybe just in setting up the problem, maybe everything else is working. I don't know. -2 times 8.8 is -17.6. 3 times 6.2 is 18.6. And when you add them together, you do get 1. That one's working. Okay, and on the second, 8.8 minus, now 4 times 6.2 is going to be, 4 times 6 is 24, 24.8, and 8.8 minus 24.8 is -16, so that checks. So the answer actually is the ordered pair 8.8, 6.2. Surprised the heck out of me. Anyway, there you go with a two equation and two variable system example. Now let's move on to 3 equations and 3 variables. Now I'm going to need to be pretty careful about this. So let's just start out with a system. How about x plus 2y minus z equals 2, and 3x plus y minus 5z is equal to -1, and 4x minus 3y plus 2z equals 3, we'll say. Okay. Now, if we want to solve this system using Cramer's rule, first of all, big D is going to be the determinant 1, 2, -1, 3, 1, -5, 4, -3, 2. Now, let's just go ahead and find the values of these things as we write them down. So I've got 1, 3, 4, 2, 1, -3. All right. 1 times 1 times 2 is 2, plus 2 times -5 is -10 times 4 is -40, plus -1 times 3 times -3 is +9. So we get 2, oh, well, wait, okay, then we're subtracting from that. Let's do that. 4 times 1 is 4, times -1 is -4. -3 times -5 is 15, times 1 is +15, and 2 times 3 is 6, times 2 is 12. Okay, so what do we get? We get -4, well, let's just do this. Distribute through here. 2 minus 40 is -38. -38 plus 9 is -29. -29 plus 4 is 33, 33 plus negative 15 is 18. 18 plus negative 12 is 6. Now I'm going to pause the video here for just a moment and run this through the calculator, because otherwise, if I make a mistake here and don't catch it, it will be confusing and a lot of wasted time. So I'll be right back. Hi, I'm back. Now, negative 6 is not the answer. It looks like it's negative 52. So let's see if we can't just straighten out what's going on here. 2 minus 40 is negative 38. Minus 9 is negative 29. I think I said that. Okay. And then we have 4 plus negative 15 plus negative 12. Now, 4 plus negative 15 is negative 11. Negative 11 plus negative 12 is negative 23. So we're adding negative 23. And negative 29 plus negative 23 is negative 52. So I'm happy with that number now. So I'm going to erase, not the matrix, but I'm going to erase all this math. I'm just going to move the 52 over here so that we'll have more room. So the value of big D is negative 52. Now, the numerator determinant, n sub x, is going to be 2, negative 1, 3, 2, 1, negative 3, negative 1, negative 5, 2. So now let's see what we get. 2 times 1 times 2 is 4. Excuse me. 2, negative 1, 3, 2, 1, negative 3. 2 times 1 times 2 is 4, plus 2 times negative 5 times 3 is negative 30. Negative 1 times negative 1 times negative 3 is negative 3. And then minus 3 times 1 times negative 3, that's negative 3. Plus negative 3 times negative 5 times 2, that's 30. Plus 2 times negative 1 times 2, that's negative 4. Okay, so we get 4 plus negative 33 plus 3 minus 30 plus 4. Well, let's see. If I were to group these two together, I'm going to get negative 66 and then negative 66. And if I group these together, I get positive 11, and that gives me negative 55. Let's go back and just check, see if I've made a mistake. I'm going to pause here again. I'll be right back. Hi, I'm back. I'll bet you caught this. Negative 33 and negative 30 is negative 63, not negative 66, which gives us a negative 52 here. Okay, so I'm going to just say equals negative 52 again up here, and I'm going to erase this now so that we'll have room. All right, let's see if we can't get one of these done without my making a mistake. Let's try n sub y. N sub y is going to be 1, 3, 4, 2, negative 1, 3, negative 1, negative 5, 2. We write 1, 3, 4 again, 2, negative 1, 3 again. Now, 1 times negative 1 times 2 is negative 2, plus 2 times negative 5 times 4 is negative 40, plus negative 1 times 3 is negative 9, and then from that we're subtracting 4 times negative 1 times negative 1, that's 4, plus 3 times negative 5 times 1, that's negative 15, plus 2 times 3 times 2 is 12. Okay, so this becomes negative 51, negative 2 plus negative 40 is negative 42. Negative 42 plus negative 9 is negative 51. And from that, we're subtracting, whoa, look at this. 4 plus 12 is 16. 16 minus 15 is 1. So we're subtracting 1. Negative 51 minus 1 is negative 52. All right, so for n sub y, we're getting negative 52 again. I'm going to put that here and erase what we've got here. Hopefully there'll be enough room to get n sub z in here. Let's see if we can't find some other color. How about this color? Okay, so we've got n sub z. Now n sub z is going to be 1, 3, 4, 2, 1, negative 3, and 2, negative 1, 3. And we write 1, 3, 4 again, 2, 1, negative 3, and let's move up here a little bit so we get a little room. Now, 1 times 1 times 3 is 3, plus 2 times negative 1 times 4 is negative 8, plus 2 times 3 times negative 3 is negative 18, minus 4 times 1 times 2 is 8, plus negative 3 times negative 1 times 1 is 3, plus 3 times 3 times 2 is 18. Okay, now 3 minus, well, let's see, 3 plus negative 8 is negative 5, negative 23 for this part, minus, now 8 plus 3 is 11, 11 plus 18 is 29, so we have negative 23 minus 29, which is negative 52. Okay, now I bet you noticed that we've got some magic going on here. So let's see what Cramer's rule says all this is going to be. Now Cramer's rule says that x is going to be equal to n sub x over big D, that's negative 52 over negative 52, or 1. Y is going to be n sub y over D, negative 52 over negative 52, which is again 1. And z is going to be n sub z over D, which once again is negative 52 over negative 52, or 1. So how did this go? If x is 1, y is 1, and z is 1, we get 1 plus 2 minus 1, that's 2. We get 3 plus 1 minus 5, that's negative 1. And 4 minus 3 is 1, plus 2 is 3. And so 1, 1, 1 is the solution to this system of 3 equations and 3 variables. Now, one other thing that does need to be talked, well, not one other thing, but one more concept that needs to be talked about in this video is what happens when you have systems that don't have solutions or have infinitely many solutions. Now, that's pretty easy to take care of, but let's just kind of take a look at it. Now, if we get a system where n sub x is, say, 7, and the coefficient matrix D is equal to 0, then Cramer's rule is saying that x is equal to 7 over 0. Now, 7 divided by 0 is undefined. Mathematically, there is no number that is 7 divided by 0. Somebody the other day showed me what Siri does when you try to divide by 0. So sometime if you're interested in being amused, ask Siri what you get when you divide by 0. But anyway, there is no number that is 7 divided by 0. So if you get a Cramer's rule where you've got a non-zero number on the top and a 0 on the bottom, there are no solutions. Now, if instead Cramer's rule gives you, say, n sub x is 0 and big D is also 0, then what you get is x is equal to 0 over 0, and this is indeterminate. In other words, this could be any number, we just can't tell from the information we're given. And so when you get 0 over 0, you get infinitely many solutions. So in Cramer's rule, it's also important to know what happens when you get zeros in this ratio. Now, obviously, if the numerator determined is 0 and the denominator isn't, that's 0 over, say, 7 or something like that, and that's just 0. 0 on the top is fine. It's when we get 0 on the bottom that we have trouble. And so when we have 0 on the bottom, there's one of two ways we will go. It will either be no solutions in the case of the value for x being undefined, or it will be infinitely many solutions if the value for x is indeterminate. And strangely enough, if this is a system, then if you get undefined for x, you would also get it for y and z. If you get infinitely many, or indeterminate for x, you'd also get that for y and z. So that takes care of Cramer's rule. And we're done.